So let's take a look at it. The idea with this lab is you're going to create a computer program that plays tic-tac-toe. And we need some way of looking at tic-tac-toe. We're an advanced C++ class, so we want to look at, I drew a circle around this saying, this is our game, tic-tac-toe. And I have X's and O's in my mind, and how am I going to represent a tic-tac-toe board in software? Well, I could have I could have 9 variables, 1, 2, 3, 4, 5, 6, 7, 8, 9, but that's a little crazy. So instead I'll use an integer and I'll call the board a board, and there are 9 variables. Board 0, board 1, board 2, board 3, board 4. All of these positions are board variables. Now, I want to be able to say if there's an X or an O in one of these positions. So what I could do is in my program, I can define constants. X equals 1 means the letter X in my program will be used for a 1. If I want to put an O in a position, I use the letter O. But it's really going to be the number 2. The same with a blank. I'm going to use the number 3 for a blank. I have to put something there. Now, how do I control this? The idea is, this is a game, and I want to have a command called reset. This is an API. These are APIs, as in an API set. So when I say reset, everything is blank. So a blank would be 3, 3, 3, 3, 3, 3, 3, 3, 3. I could use a for loop. For I equals 0 to less than 9, put a blank in all these positions. I could ask, is there a winner? Did player X win? Over here, winner, X. X is the number 1. I don't use the number 1, I use the letter X. So I can ask this function, did X win? And this function will look for a winning combination for X. I can also use it to ask O if it won. I can ask if a square is free. Someone says position 2, 0, 1, 2. Is it free? No, it's not. False. The position is not free, true or false. I can go make a move, go into position 5, 0, 1, 2, 3, 4, oops, not 5, say 4. So I say go 4, boom, an X or O will go here, depending on whose turn it is. So the idea is, in my mind, I'm going to have an array, I'm going to have these 3 constants, and I'm going to write a bunch of functions to control the tic-tac-toe game itself. The idea here is we're trying to control this as a programming monster. So there it is enlarged. Once again, don't try to study this all right now. The idea is you go home, you take a look at this. But it is that you have an array. I have, and I called it board, 9 positions, and I have variable constants, X, 0, and the word blank. And I will use these variable constants. I keep calling it a variable, but it's a what? Constant. I will use these letters, these constants, or manifest constants in my program to control things. And I will use these words, these functions, or predicates. Like predicate means something is true or false. True or false, is X a winner? Is O a winner? Is a position 5 free? Go to position 6. Display the whole board. Is the entire board full? Whose turn is it? And it's time to switch turns. So if it's X's turn, now it's O's turn. If it's O's turn, now it's X's turn. The idea is these things are going to be very simple functions that you and I would write. So you have to write down, as a designer, software engineer, you have to say, what does it mean to reset? Before I even start coding, I have to think. Notice, I'm not writing any code here. This is my thinking process. My thinking process is, I want to play tic-tac-toe. So I need to study the rules of tic-tac-toe, know how to play it. we pick tic-tac-toe because it's easy, but we could do a 4x4 tic-tac-toe game, which is a little more interesting. Well, it is interesting compared to this. But it's a foundation. So down here, I mean, up here I have my ideas, things I want to say to this bubble, this cloud. I never want to touch this board. I want to use these commands to play the game. And here, I have to explain what each one of those commands mean. Now, typically you want to develop some minimum set of functions or commands to play tic-tac-toe. It doesn't have to be minimum. You can have thousands of utility functions to play tic-tac-toe. But I say minimum because if you go too far, it's like too many cooks spoil the what? The broth. Is that old saying? Too many cooks spoil the meal? No, more salt. No, less salt. Put this spice in. No, put this in. And the same in programming. If you have too many too many functions to choose from, it's hard to make a decision. But you need a small set that can do everything. So I pick reset. I can ask if something's a winner. Here, ask, is X a winner? Returns true if and only if. IFF means if and only if. X has 3 in a row. And otherwise it's false. Likewise, if I ask if O is a winner. Is some position, some square, S, free? Precondition. I'm saying, well, S can't be less than 0, and it cannot be equal to or greater than 9. It's got to be less than 9. And I ask, returns true if board of S is equal to a blank. Otherwise, returns false. So notice there's no code really written here, but it's an idea for how to write code. So I asked myself, did I come up with a set of commands to help me play the game? This is the most complex one, possible winner. I'm going to say X or O. X or O is a number. Right here, X or O. Is X a possible winner? Return the position of a win for a player on the next move. So if I say, here's X. Could X win on the next move? So give me the blank square where X can win. If you can't find a win, then you put a negative, then you return -1. Can't win. So next, use these rules to create a program that plays tic-tac-toe. Also called noughts and crosses. Now sometimes after you sat down, you have written all these rules, you find out, oops, I forgot something. It's like great art sometimes. You know, you start on a painting or a movie, and you're working through the movie. You don't know what the ending is until you get there, and it's in post-production. That is after everything's done. You sit down, you edit, you look, you edit, you look. 2 years go by, and finally you have a movie. Well, here we go. Here's my game, a new function. First thing I do is I reset. Bless you. Show the rules of the game. Now I didn't write show rules, did I? But I said, I'm going to need this, so I just wrote it down there. I can figure it out, what? Later. Tomorrow, tonight, let's outsource it. Next, I figured who goes first. Oh, I need to ask who goes first in the game to find out who the first player is. X or O. Then I have a loop here. Do while. Display the board. Go get a move. What do you mean? Whose move is it? I didn't write get move. Well, get whoever's turn is it. Get the turn, give it to get move, and tell me what their move is. Then I take their move and I go make the move. Then I ask, hey, whoever's turn is it right now, are they the winner? They just made a move. Look at this. This is kind of beautiful in a sense, a little complex. If whoever's turn it is the winner, game is over. Break out. Now notice I put a comment there. Game over. That's I think a very nice comment there. Otherwise, switch turns. It's someone else's turn. Is the board full? Well, obviously we got here, there's no winner. But are there more moves to make? If there are more moves, notice not is full. I go back up here, display the board, get the next player's move. And I make the move, ask if they won. If they win, whoever wins, I come out here and I say, if the board was full, then it was a draw. Else, if it wasn't full, well, it could be full too. This one has a bug in it. There's a bug. If it was full, it was a draw. But that's not quite true, is it? We need to test to see if someone won the game and who won. So there's a bug in this logic, but the idea is you get out and then you ask, well, whose turn is it? If it was X's turn, then X is the winner, else O is the winner. There's a slight logic bug in here, in it. Yes?
What's the thing inside of do well and do one stop?
There are many, many ways to do this. Many ways. And this one actually has a minor bug. But it kind of works. If you wrote this and played it, the game would work with a couple of hiccups in it. If somebody wins at the last move, it's not necessarily work. It doesn't work right. Now that's a general idea. But now, we're scientists or aspiring scientists, software developers. So we have to dig in deeper. We just get, oh, it's tic-tac-toe. No, we have to dig in further. So you could read this at home. Don't read this now. But one concept is random play. Suppose I don't want just man versus man, machine, human. I want human versus machine, or machine versus a machine. How does a computer make a move? Well, we could have a random move, and the idea would be, well, we pick a random number, M. I don't know if you can see that code. I'll enlarge it to make sure. Again, you study this when you get home. You take a look at the code here. Here we have a random number. It says divide by 9. When you divide by 9, what's your remainder? 0 through 8. 9. That's the oldest trick. Got ya. 0 through 9. I got myself. 0 through 8. So it'll be one of the moves on the tic-tac-toe board. And then I ask, is it free? Can I go there? If it's not free, go back and make another move. It just picks a random number and goes there. Not the greatest function, but you know what? You can play like that. The computer just picks a move. Next, we could come up with, and here there is, a perfect game. Or we could have an imperfect game, where we set up a bunch of rules. On the first turn, always go to square 0. The first player always goes to square 0. The second player, second move, if square 4 is empty, 0, 1, 2, the middle square, then go to the middle square. If the middle square has someone in it, then you take the corner square. It's the second move. What about the third move? Well, the third move, check the bottom corner, number 8, bottom right. If it's free, go to the bottom right. And if you think about what this is trying to do as a tic-tac-toe game, it's trying to do the classic go here if it's free, and if this is free, go there. 0, 1, 2. If somebody went here, then go up there. It's picking, it's picking one of those two spaces to go to. It's a set of rules. And if these rules are written down correctly and followed, it's a perfect game. You're either win or draw, no losing. Let's take a look at some of the other functions here. Notice it is free and go. We talked about them a few minutes ago. Here, we can ask the question, Can X win on the fourth move? The even move. Can X win? That's me. If I can win, then this will be a positive number. It will not be equal to -1. If it's not equal to -1, that means I can win. So go find out what that number is and win the game. If I cannot win, I go over here and I say, go make 2 in a row. Just find this empty square next to one of my X's and go there. Now I didn't have this one before, but I realized I needed it, so what do? Just pretend it's there. So, okay, make 2 in a row, and I say, who am I making it for? In this case, I want to block, I think I want to block O. Next, the next person says if I, did I get this right? Oh, it looks like I did a cut and paste here by accident. They're supposed to be opposite now. All right, so if I'm O and I can win, then O should go and win, etc. There's a bug in this too. But notice the idea is I get to reuse these functions like hammers and screwdrivers and things of that nature. They're reusable tools. These are APIs. So this could all be converted into one program. And so this is on the internet. Just don't copy and paste it. It's there already. There are 2 other things. The compression tic-tac-toe board we're not going to look at for a week. But tic-tac-toe project we're going to look at. It's just an idea. Because I understand sometimes you guys need projects. Big projects. And the idea is, well, when you have a project, you need some sort of a vision. Notice this is retooled. This is like 5,000-year-old thing. It's supposed to be the people, if the people have no bill. So here's my vision. I have a computer main program. It runs a game. It has our board, and we can give this board commands. We can say, where is O, who's winning, who's losing, display the board. And then I have this webcam set up, just like a webcam over here. And it uses free software, Open Vision, and it looks at the board. And now that instead of getting moves from a keyboard, it figures out what's going on by getting a photograph, just like Facebook identifies your face with facial recognition. It's a facial recognition program, except the only 2 faces we have are X and O's. Next, when the computer's turn to make a move, it has a little robotic arm. You can buy these things, program them, and they can go X, O. So if you were going to do any project at LaGuardia or elsewhere, one of the first things you need is your vision. Then after you have your vision, what do you need? Your team, your resources. Projects are giant puzzles with many, many pieces. And the idea is if you assemble a good team, you can pull everything together. So you have your initial research. What are you doing? Well, your vision, research. The team, software, hardware. How are you going to talk to each other? And the time frame. There's also money, but I'm not bringing all that in here. You're undergraduates. Things are always done cheap. So teams are very, very important because no one is perfect. One person might be able to do it all. Maybe someone thinks they can, or someone will make a mistake. But if you have a team, someone messes up, it can be patched. When you have a team, you can have parallel activities. For example, 1 person or 2 people could be looking at free software, Open Vision, and figuring out how to get it to work. We're in C++, and you know Java, but there's also a language called Python that people like because it's supposed to be easier. And there's lots of online tutorials, so 1 or 2 people could be looking at this. Somebody else could say, well, where are we going to get a robot arm? We don't have one. Well, you can pretend you have a robot arm. There's simulation software. It's like a video game. A pretend arm. You program it just like you program a real robot arm. But instead of an arm moving, this picture is moving around instead. Of course, somebody has to study the problem intently, come up with ideas and thoughts, the logic. Are you going to have a perfect game? Are you going to incorporate features of artificial intelligence? Well, that might be fun. Imagine doing a mobile app for kids obviously, that when you first initialize the Tic-Tac-Toe program, it plays randomly against the kid. So it can lose. But as the kid's beating it, the computer program is learning by having a database. Don't do that. I lost last time. No, not going to make that move. And it builds up a list of don't do, don't do, don't do, don't do, don't do. So it gets sort of what? It seems like it's getting smarter, doesn't it? Because it's got a list of don't do's. Or do's. Yes, you could either way. However, when programs get smarter, they get more complex. There's the random play. Here's the set of rules. And even if you're not working on a big project alone, the idea is you have a development process. Brainstorming, you have to brainstorm. Use your imagination. Think about what have I done in the past in programming. You come up with an idea. How might you do it? For loops, while loops, the main, and we're introducing classes now. You come up with incremental development. That is, you get something working that kind of says, hello, everybody. It does a little bit more, and a little more, and a little more. You can test your program in stages. Of course, you always have to test things. We're not really worried with deployment. Your deployment is uploading your program to me. That's your deployment. Release to professor. But when you go into the real world, you don't want to just release to the professor. You want to put this on GitHub. G-I-T-H-U-B, GitHub. So you can show people when you're applying for a job. These are projects I've worked on. C++ is a real low-level language. If you survive this, move up to C#, Python, or so you can start working, or stay in Java. Java's only one higher, I think, than C++. But there's opportunities there more than C++, I think. But it's a very powerful language. I like C++. So with all of this, you have one team maybe working on a Raspberry Pi. Anyone remember the computer club? Or the computer engineering club? Well, this is a good opportunity. Today's Wednesday, isn't it? I wish I knew where they were. They're elusive. It's like, where are they hiding? It's like you gotta earn it. Wherever they are. If you're in the club, you can propose projects to them, and they actually have money. Why? How much do you pay student dues every year? 200? Maybe it's 400? 400? Some people are saying yes. You don't know what you're paying students?
I think it's 2 something.
2 something a year?
Yeah.
That's your money. It's student dues. When there's a club party, that's where the money comes from. Now you think that we have so many, how many thousands we have here? Say we have 10,000 students. We have more than 10,000 students. You can go online, look it up. At $200 a pop, what is that, 200,000? Something like that, a semester? It's quite a slice of pie there. And if you go to the computer club, and you can get them to, you can propose it, say, hey, let's do a project together. Put it on our resume, get a team going. I realize many of you here have responsibilities, you can't stay around, but if you could. So here would be one team trying to get, it doesn't have to be a Raspberry Pi, this could be the PCs in the lab, trying to get a webcam to recognize X's and O's and just say, there's an X in square 0, there's an O in square 1, there's a blank in square 2, thank you, etc. That would be the objective of that team. Another team, their objective would be to try to get this crazy robotic, I hope you like my artwork, this crazy robotic hand to write X's and O's in the right spot. We have another team trying to design the overall system, how everything is going to work together and coordinate people. For example, time frame, milestones, who's responsible, how do you test it? Is this good enough? You need some documentation. Even if you put this on GitHub, you're going to have to write a file called README. So when people go there, they say, what's this code about? I don't know, it says Tic-Tac-Toe. It's 3,000 lines of code. I'm joking, but it's like 500 lines of code, 1,000. What am I going to do? Well, how do I even, what's going on? Ah! So you need some documentation, and then you want to demo it. After you're done with this project, you want to get something out of it. So when they have faculty and student demo day for projects in the atrium, you go there. It goes on your resume, all this stuff. And companies will ask you questions. What have you done? Senior colleges will ask questions like write letters of recommendation. They go, has a student participated in the greater college community that I'm aware of? And if you write on projects or been on a team that did a project, I write about it. I say, oh yeah, he was a great project, was hard worker. Beyond the scope of the material in the class.